Okay, so to find the left and right hand sums when n is 5, I'm going to look for 5 intervals. So I see here we go from 0 to 5, so each change in x is my interval. So the left-hand sum is 1 times 36 plus 1 times 30 plus 1 times 23 plus 1 times 15 plus 6. We're going to add all of those up, and we get 110. The right-hand sum, that starts here and goes all the way to the right. So it's 30 times 1 plus 23 times 1 plus 15 times 1 plus 6 times 1 plus 0 times 1, which is 74. So to actually estimate the integral, we're going to find the average of the two left and right hand sums. So 110 plus 74 divided by 2 equals 92. We're going to do the same thing for B, except now I notice that each x is increasing by 2. So for my left-hand sum, it's 2 times 2 plus 2 times 3.9 plus 2 times 5.4 plus 2 times 6.6 plus 2 times 7.4. If you were looking to save yourself some typing in the calculator, since every number is times 2, you could do 2 times the sum. So adding all of those up, we got 2 plus 3.9 plus 5.4 plus 6.6 plus 7.4 times 2 and that is 50.6. So we're going to do the same thing for the right-hand sum. It's going to be 2 times 3.9 plus 5.4 plus 6.6 plus 7.4 plus 8, and that is 62.6. We could then find the average of the two left and right-hand sums to find the estimate for the integral. So let's do that. 50.6 plus 62.6 divided by 2. That is 56.6. Now another way to estimate an integral is to actually look at a shape that the graph would make. So if I'm going to draw 9a, the graph is x plus 1. So it's a y-intercept of 1 with a slope of 1. So we get a straight line like this. But I only want the area between 1 and 4. So this y value is going to be at 5. This one's at 2. If I plug 1 into my function, 1 plus 1 is 2. If I plug 4 in, I get 5. So I need this area here. That shapes a trapezoid. This is the height of the trapezoid. This is the bottom base. This is the top base. So the area of a trapezoid is half the height, base 1 plus base 2. So by plugging in all my values, that's half of 3 times 2, times 2 plus 5, and that equals 21 halves. So if I draw C here, it's going to give me a semicircle from -4 to 4. And I want this whole area between -4 and 4. So that's half of pi r squared. The radius is 4, so that's half pi times 16. So that equals 8 pi. And we want exact values, so don't plug pi into your calculator. So drawing B, it's going to give me a semicircle again from -2 to 2. But I want the area only from 0 to 2. So that's from here over. So that's a quarter circle. And in this case, the radius is 2. So my area is pi. Okay, so then drawing D, you could use your calculator if you wanted. I hadn't used it for the prior ones. You can do 3 plus the square root 9 minus x minus 2 squared. So what we're seeing here is a semicircle raised up. So if I'm going to draw that, the semicircle starts, so if I hit trace, around -1, and I bet it goes to 5. It does. And at 5, there's a y value of 3. But my integral starts at 2. So what I'm looking at here for my area, just this piece, it's a rectangle on the bottom and a quarter circle on the top. So the rectangle is base times height, and then the quarter circle is a quarter pi r squared. So this is 3 by 3, so that's 9. And the radius here is 3. So simplifying, I have 9 plus 9/4 pi. And that is our area. So now for number 10, to write an integral for the distance, well, the integral for the first 5 seconds is 0 to 5 of the velocity will give us the distance. So if I actually calculate that, you can use our calculator, or you can use the fundamental theorem of calculus, since we know that now. And that value is 66 2/3, or 20, or 200 over 3, which is 66 2/3. So for 11, it says use the calculator method. So hitting the math button, and option number 9 is an integral. Or if you prefer to see it visually, we can graph it. So I'll do the graphing for A. Put x squared into y1, and I'm going to look on -10 to 10 is a fine window. Then we're going to hit second trace for the calculate menu, and choice 7 is the integral. I have to set my lower and upper limits. So my lower limit is 0, my upper limit is 5. It's going to shade in the area and tell us that that integral equals 41 2/3. Okay, I'll do B the math way, so I do math, option 9. I have to input my function. Comma, the variable we're integrating by, which is x, and then my lower limit and my upper limit. We get 6.857. You can choose either method to do C or D. Now for number 12, finding the area between the graph and 0 to 6 and the x-axis. I'm going to look at that function in my calculator. And I'm only going to look from -1 to 7. And so looking at that picture, if that's going to be this area plus this area. But understanding that an integral just calculates the Riemann sum, or all of the rectangles added up, this area down below the x-axis is going to be a negative value. So if I want the total area, or the space that these two pieces of the graph take up, first I have to find where does this cross the x-axis right here to split up my two pieces. So I'm going to do second, calculate 0, to go to the left. Right. Yes. And that's exactly at 2. That means this one's exactly at 6, right here. So if I find the integral from 0 to 2 of my y, and subtract the integral from 2 to 6, because this is a negative value, my minus a negative will give me a positive. So let's actually calculate. So my lower limit is 0. My upper limit is going to be 2. So that's 3 1/3 minus. Now I have to clear that, so I'm going to go to my draw menu and clear. So again, I'm going to calculate the integral, but now this time from 2 to 6. That's negative 21 1/3. So if I combine our numbers here, minus a negative is really plus. We're going to get 24 2/3. Now when we do the whole integral, from 0 to 6, I'm expecting a negative value because more of the graph is below the x-axis than above. So that means that the value of just the integral itself is going to be negative because more is below the axis. We get negative 18. Could also calculate that by doing 3 1/3 minus 21 1/3. So the answers to A and B are different because A is asking for area, which is always positive. It's the space that the graph, the two regions take up. Where B is just asking for the integral, And because more is underneath the x-axis, it's a negative value. If more had been on top, it would be a positive value. Okay, for number 13, I'm going to draw my graph twice, so I can draw two different pictures, the left and right hand sum. I'm going to use the calculator and the table to help me get my y values. So 0, we're at 2. 1 is 3, 2 is 6, 11, and 18. Now, because I made a sketch, my scale is not great. If we actually look, it is a curved graph. So I'm going to fix that here. It's a parabola because it's x squared. It'll look like that. Now I need that twice so I can do my left and right hand sums. So I'm just going to copy and paste mine. So to draw the left-hand sum between 0 and 4, I need my graph to connect over here. Okay. So to draw my left-hand sum, I'm going to be on the left of the graph and make my rectangles at these y values. So I'm going to go up at 2, and then to the y value at 3. So this is the left-hand sum. That's this rectangle, this rectangle, this rectangle, and this rectangle. If I was actually going to calculate it, that would be 2 plus 3 plus 6 plus 11. Now for the right-hand sum, going to go up on the right, so it's starting at 1 and make a rectangle. And then 4 is all the way up here at the top and over. So the right-hand sum is an overestimate. It's the y value at 1 plus the y value at 2, 3, and at 4.